8.1 Day 2, Example 2, Graphing y equals negative ax square where a is greater than 0 and then the sign in the front is negative. Graph y equals negative 2x square. Then compare that to the graph that we had it originally, and that graph is y equals x square. First of all, to graph y equals negative 2x squared, we want to make a table values. And we are going to use the x values and plug these x values one by one into the y value to get the y coordinate. So first point we are going to use is negative 2 times negative 2 square. Whenever we take a square of a negative term, it becomes positive. So negative 2 square is positive 4. And that point are going to be negative 8. So my first point is going to be negative 8, negative 2 comma negative 8. My second point, when I use y equals negative 2 times negative 1 square, and that's going to be negative 2 times 1. And that's negative 2. And the point is negative 1 comma negative 2. Next is y equals negative 2 comma 2 times 0 square, and that's going to be 0. Next point is 0 comma 0. And y equals negative 2 times 1 squared is going to be negative 2 times 1. And the point is 1 comma negative 2. And last one is negative 2 times 2 square. Negative 2 times 4 is negative 8. And the point is 2 comma negative 8. Now we are going to plot all these points and see our graph. And that is going to be facing down graph. Why is going to be facing down? Because we have a negative in front of the A. I'm going to plot these points. Negative 2 comma negative 8 is this point right here. Negative 1 comma negative 2 is this point. 0 comma 0, 1 comma negative 2, and 2 comma negative 8. You connect these points and you will get this smooth graph. This graph is skinnier and it's stretched vertically because it has a number in the front that is greater than 1. So if you have 2, 3, 4, 5, 6 and so on, you're going to get a vertically stretched graph or narrow graph. You're going to compare now this graph with our original graph, that is y equals x squared. Now I'm going to do the y equals x squared graph. We doing this graph, but let's make a table values for this graph. I think we made the table values for this graph earlier, but right now you're choosing x value and finding out y values. I'm choosing negative 2, negative 1, 0, 1, and 2. When you plug it in negative 2 into this equation, you get negative 2 square, and that is 4. Negative 1 square, and that is 1. 0 squared is 0, 1 squared is 1. And then when you put the 2 in 2 square, that is going to be 4. So the points are going to be negative 2 comma 4, negative 1 comma 1, 0 0, 1 1, and 2 4. So 0 0, negative 1 1, negative 2 4, 1 2 3 4, 1 comma 1, that is this point, And 2 comma 4, the last point is going to be 2 comma 4. You're going to make a smooth graph out of these points, and you're going to get a regular graph. Now, if you compare this graph and this graph, what do you notice? This one is facing up because it has a number that is in the front is positive. This graph is facing down. The red graph is facing down because the number in the front is negative. What else do you notice in these two graphs? This graph is a regular looking graph, whereas the red graph is skinnier and taller. Why this red graph is skinnier and taller? Because you have a number in the front, and that number in the front is greater than 1. So it's 2, 3, 4, 5, 6, or 7. Then it's going to have a taller and skinnier graph. I want to take your attention, everyone, to this graph that is our regular y equals x graph. We call it parent function as well. Whenever we make a points for parent function, we always have the point into x comma y form. Y is the square of x. So if you notice this carefully, that this x is a x value, and then this y is a square of x. So whatever you choose for x value, so if I choose -1 for x value or -2 for x value, then y is going to be square of -2, that is 4. If I choose -3 for x value, then y is going to be square of -3, that is 9. If I choose -1, then y is the square of -1, that is 1. If I choose 0 for x, then y is be 0 square. If I choose 1 for x, then y is going to be 1 square, that is 1. If I choose 2 for x, then y is getting its square, and that is 4. So it's really easy to get the points for the x square. It's going to be 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, so on. Whatever you choose for x, y is going to be square of that. Whatever you choose for x, y is going to be square of that. So it's really easy to get the points and graph this parent function. You're going to do the you try problems in your notebooks. So these are the 2 problems that you're going to try. Now you're going to do the example number 2, but this time the a is going to be less than 1. Before we used the a, that was 2, which was greater than 1, but right now this 1/3 is less than 1. And now we are going to compare this with the parent function. As I said in my previous example, y equals x square is very easy. The point for these ones should be 0, 0, 1, 1, 2, 4, 3, 9, and so on. 0, 0, -1, 1, and 2, 4, 3, 9, so on. And you make a parent graph. For the next one, for making a graph that is y equals 1/3x squared, we have to make a table, and we are going to use these x value and plug it in here one by one to get the y value. So first thing we are going to do is plug it in the x value as -3. So what you got here is 1/3 of 9. So that's going to be 9 divided by 3, and it is 3. So my first point is -3 comma 3. Next is that I'm going to use the x value as -1. 1 over 3 times 1, that's going to give me 1 over 3 or 1/3. It is also 0.33. So my next point is -1 comma 0.33. When I plug it in 0 for x value, so 1 over 3 times 0 going to be 0. So the answer is 0 comma 0. When I choose x equals 1, you're going to put that x value as 1 in here. You got 1 over 3 times 1. So that is 1 over 3, and that point is 0.33. So the next point is 1 comma 0.33. And the next one is 1 over 3 square, and that 1/3 of a 9. 9 divided by 3 is just 3. So my next point is going to be 3 comma 3. If you notice now at this point, I want to take your attention on the symmetry here. Whatever you got this point for a -3, that's exactly what you're going to get for +3. For -3 you got 3, for +3 you got 3 as well. Since they are symmetrical values, whatever you got for -1, that's exactly what you got for +1. Whatever value you got for 2, you got for -2. Sometime it is recommended that you make one side, so you make 0, 0, 1, 1, and 2, 4. The other side, you mirror these points. So if this is one step from the y-axis, this is also one step from the y-axis. If this is 2 steps from the y-axis, this is 2 steps from the y-axis. Because this part is same as this part. We already said that this is a symmetrical figure. Whatever is this part, same as this part. So that's why these points are same. 0.33, 0.33 is also same. You can see that when we graph this point, when we graph this, is going to be again symmetrical figure. My first point for this red graph is going to be -3 comma 3. So that is this 1, 2, 3, -3 comma 3 is this point right here. -1 comma 3, 3 is this point right here, and 0 comma 0 is this point. And then I don't have to graph these 2 points, like plot these 2 points. I can just mirror these points on the other end. So if this is one step, this is going to be one step. I just mirror this point right here. And if it is 1, 2, 3, 1, 2, 3, this is the next point. I don't even have to make the table for the full values. And then I'm going to make a smooth graph and connect these points to get a graph of y equals 1 over 3x squared. Now we are going to compare these two graphs. The one graph we have is the original graph, that is y equals x squared, and that is our original graph. And the other one is we have here is y equals 1 over 3x squared. Both of them are facing up because both of them has a positive sign in the front. This graph is a regular look graph, but the one with the 1 over 3 is a wider. So this one is a wider graph and is pressed down. So it's a wider graph that is pressed down. Both of them has axis of symmetry x equals 0 because the vertex for both the graphs is 0, 0. So this is the vertex for both the graphs, 0, 0. Next, we are going to try the you try problem number 1 and number 2, where we have a is less than 1. We are going to make a table in order to solve this. So to graph this, I'm going to make a table. So the x value that I chose is -1, -2, -1, 0, 1, and 2. And I'm going to plug these x values one by one into this value to get the y values. So when I plug it in -2 into here, I got 1 over 2, 2 square, or -2 square, that is 4. Half of 4 is 2, so my point is -2 comma 2. So -2 comma 2 is this point. So -2 comma 2. Next, I'm going to choose -1. When I plug it in -1 here, I got 1 over 2 -1 square. -1 square is just 1. Half times 1 is 1 over 2, that is 0.5. So my next point is -1 comma 0.5. -1 comma 0.5 is in the middle. Next is when I use x equals 0 and plug it in here. 1 over 2 times 0 is 0. So this is going to be the point 0, 0. Now to graph the other 2 points, I'm going to just mirror this point here, mirror this point here. So my point is this one and that. Combine these points, you're going to get a graph that is a wider graph, and that is y equals 1 over 2x squared, where the vertex is 0, 0, and is a wider looking graph as compared to a parent graph. Next, I'm going to graph 1 over x squared, where I'm going to choose the x values -2, -1, 0, 1, and 2. All I need is these 3 values. I'm going to mirror these values after that. When I choose -2, it's going to be 1 over 4. It's going to be 1 over 4 -2 square. Remember, -2 square is 4, and 4 cancel. You're going to get 1. So -2 comma 1, and that is going to be this point right here. -1, when you plug it in -1, you got here is 1 over 4, and that is going to be -1 square. -1 square is just 1, so that's gonna give you 1 over 4. 1 over 4 is a quarter, and that is 0.25. 0.25 is point right here. Next, you're going to plug it in 0. Anything times 0 is 0, so your next point is 0 comma 0. So we have a point here, -2 comma 1, -1 comma 0.25, 0 comma 0, and mirror this point on here. You got 2.5. Mirror this point on the other side, and you get here is a wider graph, even wider from the previous graph, because now it is 1 over 4. The number on the bottom, if it increases, the graph become wider and wider. Next, we are going to discuss the key idea. Key idea when a is greater than 1. If a is greater than 1, the graph opens up because it's positive. And if a is greater than 1, it means we are talking about something like y equals 2x squared or y equals 3x squared, something like that. For this type of graph, the graph is going to be narrower vertically. So it's going to look like something like this, tall and narrow graph. It is a stretched graph from the original graph. Next is when the a is less than 1. This is the type of example where you have y equals 1 over 2x squared or 1 over 3x squared and something like that. In this case, the graph is of course opens up because a is positive, and it's going to be a wider looking graph. And it's going to be vertically wider or vertically shrunk graph as compared to the parent graph y equals x squared. When you're talking about the last one, that is when a is less than 0, that graph is when you have a negative in front. It can be just y equals negative x squared, negative 2x squared. In this case, the graph is going to look or face down as compared to the parent graph that opens up.